Hello, my name is Stefan Holländer. I'm leading the MEA organization for Formlabs, and we are pretty happy to have a recording here in the famous Funkhaus in Berlin, as we are for the first time attending the annual event from Systematics here virtually, which is pretty amazing. Obviously, I have not seen a hairdresser for quite a while because we have been lockdown mode for a while, and we are also extremely jealous about the big success that you guys have in Israel, obviously, with the vaccination process. And I wish we would have the same situation here in Germany, as it right now turns out rather to become something like our famous Berlin airport that just finished with, I think, 5 or 6 years delay. So somehow embarrassing, but at the same time, it's good to see that you guys are well on track, and we're very excited about that. And in general, of course, COVID was a big story for us last year. It was a big disruption, I guess, to most of the industries. But I think if you talk about 3D printing, there was also a little bit of an upside. So we saw a very encouraging year. Of course, we had to adapt in the beginning as well. But at the same time, we saw a pretty different behavior in individual verticals that we normally address. So, of course, one of the things during the first wave was, of course, printing for healthcare. Healthcare is anyway an important vertical to us. So we have some very interesting collaborations with Fraunhofer and a couple of universities. We try to support them as much as we were able to during that period. And after all, we were installing large print farms across the world. You know, in the US, I think we have a pretty large one. I think the largest one is now in Asia, where we printed millions of swabs, so swabs that are used for COVID testing and which have been in short supply in the beginning. So in that sense, this was something that, of course, was important for us as an organization, that we could contribute somehow to make the whole pain a little less, and I think that was working out pretty well. The swab printing itself was to us a great case somehow, because that was kind of a breakthrough where we immediately saw a proof to the original idea of Formlabs, which is not invest into large machines and you know, have a lot of people being trained, super complex, maybe a lot of investment that needs to go in those machines. But we always wanted to go for rather the IT approach that we normally have, which is building print farms that you can start with 1, 2, 3 printers and ramp them up to the hundreds if you want. And the swab printing exercise for us was a pretty good proof point that this is possible, that it's working well, and that it has a lot of advantages to customers, because you're a lot quicker. It's easy to maintain. And I mean, from an investment perspective, that goes without saying, it does make a lot of sense, because you can scale your production in both directions. And that was pretty beneficial during that period. And now, if we go away from the healthcare industry and the medical field and address a little bit more the engineering field, that is, of course, something that, as far as I know, Systematics is most likely close to the heart of everybody in the audience right now, and to us as well, because overall the supply chain, especially in engineering, is something that got also some sort of disruption in 2020. I mean, we saw things going well, but we also saw that, you know, for instance, containers getting short globally. So spare parts didn't arrive in time. Just-in-time systems didn't work out as they should have. Or we had customers who just like couldn't get material to make the machines working because spare parts were missing. And so a lot of our larger industrial clients turned to us and intensified their collaboration with us. And I think that is something that we always kind of found very interesting, because that was the kind of tipping point that customers started to invest even more, spend a dedicated resource, investigated if we can do small series production, how we can speed up, for instance, prototyping processes. And I mean, there are so many opportunities in 3D printing. Of course, jigs and fixtures in production lines, all that has a lot of opportunities. And I think that is something that is driving the market in general. There is estimated CAGR for the total market around 30% over the next years. So having said that, I want to talk about Formlabs, of course, and our role in that whole game. And last year was our biggest rollout for the Form 3, which is kind of the core bread and butter product of our lineup. It's here on my right. And the Form 3 is basically shipped in two different versions. So the one is a Form 3 in black, as you can see it here. We have also Form 3B, which is more addressing the dental field. So in white, of course, matching the laboratory environment, and also being capable of printing biocompatible material. The big and for us most important innovation in that product is that we upgraded the SLA to so-called LFS. And the reason for that is that we are not only trying to create a product that is faster, more accurate, and addressing even more needs from our customer, but we wanted to generate a product that is also able to run in industrial environments and making sure that we can service it quickly, that is 100% reliable for you. And in case there would be a disruption of the printing process, that we can easily fix it. And that's something that was so important to our customers. We get a lot of positive feedback on this one. And so we're pretty proud of having global installation base of approximately 75,000 printers already. And I think that's a quite nice success, a good proof point to the product. And what would you do next? Of course, we looked into who is printing, what are people printing. And one of the first things is obviously you need to make the machine larger to address needs for larger models or spare parts, whatever. And so we launched, announced it already last year, launched now finally. And as far as I know, we have in the meanwhile already the first units hitting the market in Israel. So we're pretty proud of that. And that's why Form 3L is very close to our heart right now. And we spend a lot of time to make this product visible to customers, making sure that they find the application that they want to address, have the settings ready. That's kind of our standard rollout process for such kind of a machine. Overall, it can print a build volume that is 5 times larger than a standard Form 3, which is amazing. It allows you to print in the same accuracy. And it's, of course, opening up a totally new world because, we have customers who could not work or had to assemble parts beforehand and can now print parts in one print run, which is good to see. But of course, the printer is only one part of it. The second one is software. Both of them run on the same software. We can do remote printing, which is very helpful. We can manage your print farms through software, which is also great. But it's a bit tricky to explain here without showing you all the features. But what I would like to share with you is for sure that we also invested a lot of time in expanding our resin portfolio. Resin, of course, the third big pillar for 3D printing, at least if you're in polymer printing. And resin portfolio for us is already consistent out of 27, I think it is in the meanwhile, different resins that we offer. And we just added in 2020 in a couple of areas new ones. So of course in dental, we have very interesting new resins coming up, like IBT that is just shipping right now. But we also added in the past crown and bridge, temporary crown and bridge. We have dental model. I mean, there is a full range there. So that's a pretty interesting vertical for us. For the engineering markets, unlike dental, they have, of course, very different needs. It's different requirements in the applications. So we're pretty proud to announce now Tough 2K and Rigid 10K, which is in their kind of two different variations to address different needs. So Tough 2K is a bit more the versatile product. I would say it has it's pretty resistant to strain and pressure. So it's something that most of the engineering applications would require to have. And on the other hand, we see Rigid 10K, which is our highly filled material. It's pretty impressive to see that we can use it in extensive molding applications. And in general, I think that was the reason that lately had and triggered a lot of discussions with customer about, hey, new applications coming in. How can we work with 3D printing to open up that market? So super exciting for me. I think in general, there will be a lot more coming. I think that is one of the reasons for me being excited about Formlabs, because we invest so much into R&D. We have a lot of material scientists working on new ideas, and I'm pretty sure that 2021 is also going to be super exciting for us, launching new material and expanding the application for those great products. Now, last but not least, I also would like to announce that we are right now in the shipping process of our first SLS machine. Laser sintering is something that we wanted to get into already 3 years ago. We had a lot of R&D efforts put into this one, and we always wanted to launch this machine only when we are at a quality level that all of you guys will be very excited about to have this product in your hands. And so after all, we launched Fuse. Fuse 1 is going to be also coming to the market in Israel. I'm very excited to have a couple of discussions around this one, but I know for sure that it will be more interesting for you to listen to Adam, my colleague, who is going to run you through all the technical details and is going to explain a bit more about the Fuse 1 product itself, but also about the post-processing and how easy it is to do laser sintering with Formlabs product. So thank you so much for now. I'm very much looking forward to work with you on ideas, applications for the future, and of course, in cooperation with our strong partner Systematics. And therefore, I'm very excited also to attend, hopefully in 2022 in person, and catch up on all the amazing things that will be happening until then. Thank you.
Hello and welcome. My name's Adam Horrigan. I'm working as a sales engineer here for Formlabs in EMEA. Today, it's with great pleasure that I lead you through the Fuse 1 and the Fuse Sift. One thing we're very proud of is the 30% refresh rate we're able to achieve on the Fuse 1. This means you can use up to 70% recycled powder or powder left over from an existing job or previous job. The live video feed, which you'll be able to see later on, is something that makes printing very easy to view from home, or the printer itself can view what's going on inside the printer. This is something we call computer vision. We spent a long time to patent our own technology that builds an armor around our parts, meaning that you get consistent parts and wonderful surface finish every time. Let's start by taking a freshly finished build out of the Fuse and placing it into the Fuse Sift, ready for post-processing. As you can see on the display here, all we need to do is press slide to unlock, and the door automatically pops open. The Fuse build chamber is connected by this very robust cable. All we need to do is unplug the cable, open up the safety latch, and pull out the build chamber. Now we can add the build chamber into the Sift using the same process. Same cable, just plug it straight into the Sift, lock down the latch, and the build chamber is now safely in place, ready for post-processing. Let's take a quick look into the cavity of the Fuse. As we can see here, we have quartz heater tubes. Above, we have our laser module. Using the thumb screw, we can easily release the optical cassette, ready for cleaning ahead of the next build. Here is where we load our fresh and recycled powder mixture together into the hopper. This contains up to 9 kgs of powder. The printer automatically doses powder from the hopper into the build chamber, meaning that the user does not need to worry about any calculations or manual labor here. Next, let's take a quick look at the vacuum and the Fuse Sift and how they work together in perfect unison. The vacuum here is a Class 2 vacuum that we supply as part of the complete package. The reason we recommend this vacuum is it's certified for fine particles and to reduce any risk. The vacuum is automatically plugged into the Fuse Sift, as is this hose, meaning that we don't need to plug out every time. We can just directly use the inbuilt hose from the Fuse Sift itself. The Fuse Sift has an intuitive on-screen display and also hard buttons that you can use to control the mechanisms of the Fuse Sift. An example here, if I just want to turn on the light, I can either tap on the lights here automatically the fuse light gets switched on, or I can tap on the display here and automatically the fans and the lights will switch on depending on what I tap. One of the features of the fuse sift that makes it an absolute pleasure to work with is the fuse sift's negative air pressure. This means that as soon as we start working on the sift and removing parts from a build chamber, any stray powder, instead of being plumed into our atmosphere or our workspace, is getting sucked directly into the fuse sift. Using HEPA filters, we can be safe in knowing that that powder is not going to touch us. Let's have a quick look how easy it is to remove parts from a build chamber. To unpack parts, I'm just going to hit the display icon for the build chamber. As we can see, the build chamber is lifting from the bottom to the top, and parts therefore will be removed as we go along. Now that we have a portion of the build chamber removed, we can begin to lift this powder from the cake, we call it, into the sieve, and then we can start to remove any excess powder ready for recycling. As you can see, I'm removing any excess powder and placing that powder over onto the sieve here. The sieve's purpose is to make sure that no smaller parts get lost down below and get sifted into our recycled powder. Using the provided tools, such as this brush here, we can remove any excess powder from our finished parts. The excess powder should go down below, ready to be recycled into our next build. This part, as you can see, has a lot of intricate geometries, so my job here is just to remove the bulk of powder that can be used again. I don't need to spend too much time on this process because normally we will sandblast these parts afterwards. The fuse sift is provided with numerous tools to enable you to get into those hard to reach places. Once I've finished removing the bulk of powder from these finished parts, I can place them over into my little grate here, ready to transport to my sandblasting unit. So we will repeat the task again and again until we have finished taking off all excess powder from our parts. Once we start to fill up the sift's hopper, we can simply press sift to begin to start sifting out those powder particles. So far, I've shown you how we can remove some parts from the build chamber that's currently sitting inside the sift. Now let's look at what it's like to clean up after ourselves using the handy inbuilt hose that connects directly to our vacuum. We can activate the vacuum just by simply pressing the vacuum button. Our workspace is clean and tidy, ready for the next build to be unpacked. Fresh powder from the cartridge can be easily loaded into the fresh powder section of the sift. The cartridge nozzle is the exact same size as the opening on the sift for fresh powder, meaning we don't need to worry about any excess powder loading into our environment. Once we've loaded in our fresh powder, we can begin to mix recycled powder and fresh powder together. The mixed powder will be loaded below. To choose a refresh rate, we can easily tap on the refresh rate card and we can adjust how much fresh powder we'd like to load into the machine. After we've chosen our refresh rate, we can choose fill to load in both fresh powder and recycled powder. In this case, we're going to load 30% fresh powder with 70% recycled from the previous build. The final step here, once we've taken our recycled powder and our fresh powder and filled them together into the cartridge, is to mix the powder. I'm going to lift this cartridge, which contains 3 kilograms of powder, and place it into the side of the sift, the mixing unit. The mixing unit here is also fully operational by using the touchscreen on the fuse sift. I just hit mix and set my time here for 10 minutes. This will rotate our cartridge for 10 minutes ensuring our recycled and fresh powders are mixed together appropriately. Once our powders have been adequately mixed, we can remove the cartridge and place the mixed powder into the fuse, like so. You can pull the lever to release the powder directly into the fuse's hopper. The fuse will take up to 9 kgs of powder. The fuse has 3 separate sensors inside its hopper to understand its power level and can alert you, the user, when powder is low. To start a print on the fuse, we can simply find our job and then hit print. The printer will walk us through all the necessary instructions in order to launch this print. For instance, it wants us to check for a build chamber, an IR sensor, a laser window, and that we have enough powder inside the machine to run this build. Every time you launch a print on the fuse, you will be guided through these pre-print checks to ensure maximum success. Once our printer is running, we can use a beautiful, lovely on-screen color display to view exactly what's going on inside the printer itself. So, here we can see that we're currently at about 64 layers through a job that's 135 layers. The printer does not need to fill the whole build chamber if there's only half of the build chamber of actual printed parts. Also, the printer doesn't need to wait exceptionally long times before you can remove the build chamber. An hour and a half to 2 hours inside the enclosure for cool down is all that's necessary before we can take it out and remove it to the sift for further cooling. Tapping on the printer icon lets us know the internal build temperature. At the minute, we're hovering between 180, which is the exact temperature we need to be at in order to perform perfectly printed parts. To load powder credit onto the fuse, we simply open the latch at the very top of the unit. Using RFID, the printer knows that the card is inserted and will let you transfer the credit from a card onto the printer. Exactly what we're seeing here on the display can be easily accessible in Preform. I'll just show you how. Preform is our free software. Its purpose is to help you prepare your files ready for printing. Using Preform, we can see exactly what's going on in this printer. Now, if I just tap on Fancy Strike and tap on Camera Feed, I can see live that printer printing layer by layer. The printer is also interpreting this information for what we call computer vision. If it notices a catastrophic failure or difference, it will shut off the printer, therefore saving you powder and time. Currently, we are printing at 110 microns layer height. More information can be found on our regularly updated support site. So to close, I'd just like to show you one of the parts I was sifting earlier on. This is what it looks like after just a couple minutes under a media blaster. As you can see, what we discussed about earlier on, perfect surface finish, very reliable, whether it comes to small features or very thin features, are easily accessible on the fuse. So we're really excited to hear from you and understand a bit more about your application and how we can help. Big thanks to Systematics for organizing today and Stefan for speaking before me. We wish you a great rest of the event, and please do reach out if there's anything we can help with. Thank you, and bye-bye.